Hi everyone. I think I'm back here with the data compression, Unit 1. I think I discussed like I'll be sharing a video soon on this. So this video will be a complete guide to the Unit 1 data compression. The maximum of the question that has been covered in this video is from the last year paper. I have taken care like maximum of the question that are present in the last year paper should be included here. So I have taken care of that fact here. So you can be sure like the amount of questions and the quality question that I have taken will definitely help you in answering the questions in your exam. And all along with that also it will help you to build your concept. So whenever you are going through any MCQ question, make sure that you are building the concept, not only just going through that question and then moving out. No, you have to memorize. It is always better to listen the question, and whenever I'm speaking in a video, try to just think what I'm saying and try to see the option and emphasize and then memorize how you have to keep this thing in your memory. You can like when you're moving through a book, you are moving through a pages or something, you will just see the number of question and you may not find it interactive. So this video you can take it as a complete interaction. So yeah, I will not spend more time on just giving suggestions only. So just let's move through all these questions. So first question is, what is data compression? So there were four options: to compress something by presenting it very hardly. No, it cannot be. To minimize the time taken for a file to download. No. So to convert one file to another. No, it is not a kind of change in the format. It is kind of compression. So you have to reduce the size of data to save the space. Yes, this is the correct option. So in the fourth, in all the four, you will find no. This is the only true answer. It is very simple and clear. If you know the basic of data compression, this answer you can easily give. Next is, based on the requirement of reconstruction, data compression scheme can be divided into how many broad classes? Okay, so there are two broad classes for that. There are two broad classes for data compression. Next is, yeah, next is, okay, let me hide these from next time. I'll hide and then you can just go for that. Dash compression is the method which eliminate the data which is not noticeable, and dash compression does not eliminate the data which is noticeable. So it is very simple and clear, like lossy and lossless. So here the two broad classes, whatever it has been asking here in this question 2 is this lossy and lossless itself. Okay. Next is, dash compression is generally used for application that cannot tolerate any difference between the original and reconstructed data. So you can take a minute of time and you can definitely, it is a lossless compression. It because there will not be any means there will not be any difference between the original and reconstruct of the data. Yes. So next is, what is the type of data compression? So when you see here resolution, zipping, inputting, and caching. So you have to see like in which data get compressed. So definitely that is zipping. So when you share any zip file, definitely you want to compress the size. So from that you can remember the zipping is the correct answer. Data compression involved compression only, reconstruction, or both? So it is both. It involved both reconstruction as well as compression. Okay. Which of the following is true of lossy lossless compression technique? Lossless compression is only in situation where lossy compression technique can't be used? No. Lossy compression is best suited for situation where some loss of detail is tolerable, especially if it will not be able to detect by human. Yes, it is. Okay. So you yourself find. So make this point as in like you want should understand how this is different. Okay. So then only you can remember. You have to read all those 4 points. You don't have to just see this question and remember, okay, this is the answer. No, question can be different and there can be same option, and for that some other answer can be there. So you have to memorize that. Other is, information theory was given by. So this is whenever you are studying any topic, make sure that you know that who gave this theory, who gave that algorithm, because last time I remember there was a question in data compression mentioning LZW, kind of AL, that kind of name, the name of the algorithm, the LZW algorithm, and they were different option mentioning the full form. Suppose if you're just reading, Lempel zip, okay, LZ algorithm, LZW algorithm, LZ encoding algorithm, and this, and you don't remember what is the full form of that, then it will create a confusion and you will unnecessarily lose 1 mark on that. So it is very easy to gain mark on those points. So don't leave all those things for anything. Okay. So here the answer is, see, this question was asked in our time. Like information theory was given by whom? So the answer was, it was mentioned as C.E. Sanan, not in the full name. So it was mentioned as C.E. Sanan. So this is the answer. Okay, there is Sanon's theory too. So you can, it can ask like who gave the Sanon theory, and it can only give the first name, like clad, and in that way. The next question is, the unit of information depend upon the base of the log. If we use log base 2, the unit is dash, means it is basically asking for the unit. So you know very well the use of base 2, the unit is will be bits, and for this it will be nats. When we use e, then it is nat. So definitely here, only you find this particular option where these two are correct. So if you're not aware of heartlays, then definitely this is the only combination. Okay, bit nat and heartlays, so this will be the only correct answer. So this is the way to remember. Okay, just focus on the way what I'm discussing to remember. According to C. Sannon's second theorem, it is not feasible to transmit information over the channel with dashed error probability, although by using any coding technique. So this is a small, like when you will study for the second theorem, there it is itself, it is mentioned that it is for the small error probability. Okay, so this is a direct question with no manipulation, no moving here and there. The essential condition for a good error control coding technique is, okay, better error correcting capability, maximum transfer information in bit per second, faster coding and decoding method. So I think this will be the correct answer D, because it covers all. Like it should have better error correcting capability, definitely maximum transfer should be there, and faster coding and decoding method should be there. So that the compression movement, whenever it is going, it should be at the high rate. There cannot be time latency and all those things. Dash, a code in which no code word is a prefix of another code. This is a very basic question. Whenever you will read the first second topic in the first unit, you will find this question. So this is very easy to say, the answer will be prefix code. Okay. It was the asked question, I remember well. Next one is, the set of binary sequence is called dash and the individual member of the set is called. Okay, so the set of binary, this is a kind of confusion question because people may get confused between code words and code. So what is difference between the code word and code? A set of binary sequence is called code, and the individual member of the set is called as the code word. Suppose there is 101, then we say this is okay now, this is a binary bit code, and when this 101 and we have some space and 10111, then that is a code word that is defining a whole sequence as a particular meaning of the word. Next is data compression and encryption both work on binary code. It is true. Full form of ASCII. So this is, again, a kind of gaining. Suppose if you're studying the computer science from the very beginning only, you might be knowing, what is the full form of this. So American Standard Code for Information Interchange. So sometimes what happens when you don't focus on this thing, even you miss simple questions. So these, suppose here, if in the here, this is American Standard Code for information intercast, and many other options are there, so you may get confused. Okay, so if you see in C and D, the only difference is between the system. So don't be in hurry to put on the OMR sheet, because once, suppose by mistake, because I did this mistake in hurry, I put it some other mark and I was aware, and this kind of mistake was there, only system and standard was the difference. So in this way you can lose another marks. So make sure that whenever you're putting, you are putting the proper dots. Next is composite source model is combination or composition of several sources in which how many sources being active at any given time. So the answer is very simple. It is the only one. Okay, only one source active at a time. And whenever you will study about the composing source model, it is one of the property. When you will study there, you will find it there. Okay. Next is the prefix code is also called as the instantaneous code. Yeah, this is another name of prefix code. Okay. So maximum the question what I'm discussing here, you will definitely find it in a paper, because data compression is something I told you it is my topic of interest. So I have actually tried to find the questions which were asked, and it can be easier for you to understand and gaining. Suppose if question is of 70 marks, definitely you can score 60 plus on this. Which of the following would not be suitable for lossy compression? For the lossy, it is asking. Okay, so definitely it is image, because speech, video, and sorry, text. Sorry, I was telling image, not image. It is text, text. Because if there is loss in lossy there, can be some loss. Okay, in lossy compression there can be some loss of the data, so we cannot afford to loss of the data in the text, because suppose if you're sharing the banking details and there is two zeros, 5,000, zero get removed, then it will become 50. So that kind of thing go in the text, so we have to make sure on that. Which of the following are not in the compressed format? So this is a good question. Whenever you are studying about any of the compression technique, make sure that you always remember about some of the extension that will help you. This is the option this time, maybe next time some other option can be there. So bitmap is not a kind of it is not in the compressed format. Other jpeg, mpeg and mp3. And also make sure to remember, okay, make sure to remember the full form of all this, it will help you. Next is self information should be positive. So when you will study about the topic of the self information, the very first thing that you will study on this topic as a note will be only this thing: the dash development of data compression algorithm for a variety of data can be divided into two phases. Yeah, this is a sure for two phases you can divide. For models used in lossless compression, we use a specific type of Markov process called as discrete time Markov chain. So Markov process, composite model, probability model, all this will be the part of your unit 1. So whenever you are studying this topic, make sure to take out the keynotes, the key point of that, and be specific about discrete, continuous, what it is. Okay. Data compression usually works by finding repeating patterns. Yes. Okay, it cannot delete. Suppose if it is deleting, then there is a loss, or there is a complete loss of data. There can be complete manipulation. Finding a repeating pattern and then coding it is, when it will go on the decoding part, it can easily do the decoding and coding part. Why data is compressed? So this is the way, you can remember why I'm putting this answer. So you should always have logic and reasons for whenever you are putting or memorizing any answer, you are taking any answer. You should have the concept behind that. Only this is the way you can remember in the exams. Next is why data compressed. So to optimize the data, yes. To reduce secondary storage space, yes, it will help. To reduce packet congestion on network. So yeah, basically these three are the property benefit why we are compressing the data. So all of no, optimize the data is no, sorry, optimize the data cannot be, because we don't, because as I said, we don't want to change the message. Like if suppose the message you want to give particular messaging, we don't want to change that thing. Data compression will definitely help when it is moving through the network, because the size of the packet will be reduced and the storage will also be a factor. Yeah, so I think it was my mistake to say this one. No, only D. So B and C will be the answer. Lossy techniques are generally used for the compression of data that originate as analog signals, such as this here both will be there. Speech and video will be there. So option is C. Markov model is often used when developing coding algorithm for both speech and images. So these are the key points when you study in the Markov model, you will find it. So what is the compression ratio? Yes, it is really very good question. Definitely, even sometime units can be there and it can ask you to find the compression ratio. So what is compression ratio? Just study all the 4 point very carefully. The ratio of number of bits required to represent the data before compression to the number of bits required to represent the data after the compression. And here this one is opposite. It might be saying after, before, and then. So you have to make sure, like, you should be sure, like before compression to the after compression. So this should be the key. Whenever you can just study in the form of definition or in the form of divide rule. The ratio of number of bits required to represent the data after reconstruction to the number of after before. No, so this is not. So first one, be clear on the first one. Before compression to the number of bits required after the compression. Because that is the only correct answer. Next is, if fidelity or quality of a reconstruction is dash, then difference between the reconstruction and the original is high and small. Okay, so don't be confused on small, small, high and high. It is high, small. Suppose storing an image made of a square of array 256 or 256 pixels require this much. The image is compressed and the compressed version requires byte. The compression ratio is simply that before and after the compression you have to find, and you find the option to be 4:1. Okay. So I think this is the complete go through of like 25 to 30 question that I discussed with you on the data compression. I think definitely it will help you to, just make a good command on the unit 1. We'll be coming soon with more questions on more topic. Stay tuned. with this channel to get more information. Definitely, I'll try to bring all those questions, all those concepts that were asked in exams on the real based experience. So, thanks for now. Just keep, watching the videos and let me know your feedback on the comment section. Thank you so much.